Hey folks, it's Rob Flux here with another Sunday session, and today we're going to be talking all about modern methods of construction, and more specifically, we're going to be talking about 3D printing and 3D printing of houses. And in order to do that, we've got Ahmed Masil from Luyten Technologies, Luyten 3D, I should say. So Ahmed, welcome aboard, mate.
Thank you, Rob.
Mate, modern methods of construction, the sexiest thing on the planet at the moment with regards to how do we modernize our, our construction industry. There's a whole bunch of things that we're going to go into today. But before we go too deep, why don't you just tell me a little bit about who are you, who is Luyten, and why are you the industry expert we should be talking to today? And more specifically, how did Luyten come about? 3D printing of houses just seems like super sexy, mate.
Thank you, Rob. Pleasure being with you. My name is Ahmed Masil, and I'm an aerospace engineer, a mechatronics engineer, if you will. The story of Luyten started with 4 or maybe 5 aerospace engineers who teach robotics at the same time. We were into the metal 3D printing to start with, which is extremely sexy in the aerospace industry. At the time, we were doing our PhDs at the uni, and started from a question where, where is the rocket science in building a house or building a structure? Fact of the matter is, there was none. There are a lot of smart methods out there, and for some reason, we didn't feel that it was being adopted. And then from that, all conversations kept going, and Luyten came about, which is a robotics company that manufactures purpose-built robots to help automate the construction industry. That's the start of it. To start at a very small scales to kind of validate what we call a prototype, if you will, or a product that can show, okay, is this feasible to begin with?
Feasibility is something really big in our world, mate. So absolutely. So just being very clear for those who are, weren't paying attention, you guys build the robots. You're not the builder. So you sell the robot to the builder, and then the builder then does the building.
That's correct. And we are now one of the largest manufacturers of construction robots worldwide, not only in Australia. And, the fact of the matter is, we believe it's a core value in Luyten, and this is the Aussie way anyway, that the backbone of construction industry is in the small and medium business enterprise. And to be able to address all the 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 woo-ha-ha in the media, if you will, about construction crisis. This company went under. That company, we don't have younger folks coming and joining this. Well, because it's been a boring industry for a long time. You're either born in a family that does that, or you're just doing it because it's all you know. So we thought, first, when you introduce robotics, it will increase the efficiency of those builders, and that will help us deal with the supply problem. So it's not something that, rather than trying to bring a lot of migrants, if you will, and I'm a migrant, I'd rather work Uber Eats than going and lay bricks for 40 years, So it's just one of those things that common sense needs to be applied.
Yeah, you mentioned that small scale development is the backbone. I just wanted to put some stats behind that. So depending upon the council and jurisdiction, it changes from place to place. Yeah. But anywhere between 80 and 90% of all construction, I'm talking about everything, is a small scale 6-pack and below type dwelling. Now, there's heaps of big stuff, right? But they are one building that might have 200 people in it, whereas the small scale developer is doing thousands of little projects.
That's true.
Yeah,
because we live in small houses. That's correct. That's about right. It's very close to the statistics that we got ourselves. That's the majority all around the world. By the way, it's not just an Australian story.
Yeah.
and the fact is, we need to increase that supply, and with the issues that comes with, if you will, it's a bottleneck kind of issue for the industry. There is demand, but there is also issues with doing things the old ways. The old ways, numbers of people were controlled.
Yeah.
Now you got a lot of empty houses. Everyone wants to do, how do I say, investment properties. You got folks, younger folks are not necessarily in that category, so they feel the pressure, and it becomes, a cycle. It becomes a vicious cycle where the only folks, and even if you have money, we have a weird problem also, due to the supply chain disruptions that happened since COVID. By the way, we're not fully healed from that yet.
No.
And these are things that are going to keep going. Therefore, we thought, using the most resilient material, which is in omnipresence everywhere, it's the only product that has no tariffs whatsoever on it, which is cement, and replacing a number of trades you need. If you're a builder or a developer, there is a shortage on certain trades because they're overcommitted already.
Yeah.
Well, we got to an alternative that reduces the need for 5 trades to build a wall, for example, and so that's basically our pitch. We manufacture different types of robots, whether you're in prefab. We solve certain particular problems that has to do with prefab construction, which is the form works. It takes forever to design a form and stuff, and also you need to set up a new assembly line sometimes, every time. So it reduces that high cost or high overhead that you would normally get when you're, I want to start this modular housing factory. When you have 3D construction printing in the mix, it gives you more abilities even to compete for these big jobs, to make it more economically feasible. So in a nutshell, we're asking for the same safeguards you would have in a Coke can to come into the construction industry. It's a win-win-win situation for everyone, the way we view it. There are folks who try to do this and say, okay, yeah, I have one printer, I can build hundreds of houses. We say, good on you, keep doing that, but you're delusional. This is an industry that is not broken. The people who are in this industry are hardworking. They know how to do things right. We believe we just give better tools, and this issue should be, along with, if that gets coupled with cutting red tape and other nonsense that is, if you will, exacerbating the chokehold on supply, this problem can be resolved with ease. And this country and other countries have had history, very solid history of building a nation. So I don't think it should be a problem going forward. It's just folks need to think a little bit, tiny bit.
Yeah, Australia's been very traditional in its construction industry for a long period of time, and there's always been a reluctance to change. And there's a whole bunch of factors in that we'll kind of dive deeper into as we get further into the show. But I guess I want to kind of go back a step, because people are seeing 3D printing now as a brand. Oh, we've just lost Luyten. Where'd he go? I think we just here he is.
I'm back.
Welcome back. People are seeing 3D technology as 3D printing as a new technology, but it's actually been around for quite a while. It's just starting to get traction. So you guys, for example, have been around for 10 plus years. Is that correct?
Yeah, that's correct.
Yes. Yeah. So give us some insights into the journey that you guys had to go to before it actually became production ready and kind of hit the masses, and what sort of traction are you now getting globally? Because what we're seeing in Australia is not necessarily represented globally.
That is correct. Well, Yeah, we started as a robotics company that needs to solve some of the issues in the construction site, or the pain points, if you will. If you're a builder or a developer,
That was back in
simply
2016, is that right?
that was the start of it. That's the start of the
Yeah.
conversation that I referred to. Going from there, we started small. You start with what we call a prototype. You figure out the materials. You figure out whether this going to be compliant to begin with. Like, it's nice to see a video of a robot putting layers or spitting concrete or whatever, but what is this? What can people do with it? So it was a journey of research and development to make sure that we get to what we call a TRL 9 level. Uh, and that's when we have a product that can do the following: build something that is aesthetically appealing, structurally sound, and compliant according to the NCC.
So just I just want to help people who are new here. The TRL is talking about the technical readiness level. That's a measure of, is the product that you are making production ready? So is it a real product? It's not in prototype. Can you provide warranties? Is it something that I guess people can rely on? So it takes a while to get out of prototype phase into I guess production phase. So TRL 9 is, hey, you're
that is very true, because we managed to just sell the first unit that has gone through all the electrical certification, all the electronics, all the NATA certification for the materials. That was about 2021. So you can see
NATA being the National Australian Testing Authority, just for anyone out there. So I guess for these things to go live, they have to be certified, and I just want to help our guys to.
We use a lot of acronyms at our end, so
Good, mate.
So it's a National Australian Testing Authority certified laboratories that would conduct the tests according to a standard, and the results that comes out of these tests also meeting a standard that is already there, and consequently that will lead us to be able to come up with a performance solution which people then can build with this technology, whether it's a house, whether it's a bridge, civil infrastructure. That we need to go through these steps, and it's costly and it took time, and that resulted in us having a very good product. Call it Ultimate Crete. It's sold both here and overseas. And for the robotic unit itself, because most of the folks at the time, they were buying articulated industrial robots, or it's the robotic arm that's normally welding, doing something else, and they hook up a hose and a pump and an extruding unit and say, yeah, we've done 3D printing, we can build a house, we can do. The focus of the industry was artificial, because it's something in its infancy. It was trivial and artificial, and we needed these robots, for example, are 3.5 to 4 tons. It's not just a matter of putting it on a crawler and going to a site with it. We have something called WorkSafe. If the center of gravity is not calculated and engineered well, you're liable for that. Could tip. Just like a forklift. I can't just put 4 motors and an engine and say, oh yeah, this is a forklift and it can do 3 tons. No. There are standards for these kind of to get the product there, and basically to make sure that when WorkSafe come to a site in Australia, or their counterpart authorities in the US or in the UK, where similar to how we have the swims here in a work site, in the UK they call them the WAMs, which is bonkers. It's a lot of things. Like down to, if you're running a laptop sometimes on a site, you have to have an electrostatic pad. But it happened. We've had to deal with that, so that the inspector can come and tell you, okay, that is a 3D printer. We are well aware of it. Where is the log of it? Where is the checklist? Show me your tablet. Do you have that software? When was it updated? So it takes a lot of effort to get a machine or a contraption, if you will, like the
Certified.
platypus 3D printer into a site in Australia. And that took us some time. And during that time, of course, after that big milestone where we had a product that is market ready, couple of what we call prototyping customers early on were happy, gave us feedback. Uh, yeah, we started to be able to sell overseas. Some other jurisdictions, countries have been way more expedient with their adoption compared to Australia. Because in Australia also there is another thing, Rob, which is we're very risk averse.
Absolutely.
And here's the thing about change. I'll tell you a story. This morning, I had to change my password for the email, and I had to do the two steps authentication. Apparently,
Two-factor authentication, yeah.
yeah, and because it's been a year since last year, and that pissed me off. Okay, that is something as simple as that. So for a company or a business, especially if they're on the small scale, for them to say, okay, hey, Mr. Bricky, hey, Mr. Framer, Timber, or Light Gauge, and Plasterer, and all these. I don't need you guys. I'm going to hire these three tech people whom are playing in their tablets and this big machine. It's a big investment. Yeah, I need to understand more about that. So the awareness battle became our biggest challenge, frankly.
Yeah.
And the media tends to focus only on building a house. How fast is it? Is it cheaper? Is it all that? That's all garbage, frankly. To make something cheaper, you need to scale it. Yes, it can be cheaper. Yes, if you compare it to prefabricated concrete panels, the arithmetics are very clear and linear. It will cost you this much to print it and to put it with a crane and a dogman in the same prefab, and it will cost you this much if you have to have a formwork and the vibrators and the inspection and all that. So it depends on the case. It's a case by case. It could be cheaper for double story, one story housing dwelling, but then that's all ahead of the talk. It didn't, like, we're still in the infancy. We're talking simple numeric here and there. And the fact is, because it's mostly tech companies like ours leading the charge, we've had some adoption from local builders here and there. There is always, similar to how many people are risk averse, there is always someone also who wants to be the first. And that's good. These trailblazers, pioneers, are the salt of earth. They make things interesting.
So let's talk to some of those numbers, because
Yeah.
and I want to just get some people some insight. We started
Yeah.
in 2016, a lot of time in R&D.
Yeah.
Your first printer didn't actually get sold until 2021, as I understand it.
That's
so it's a lot of time in the R&D phase. So I guess what people are seeing is, hey, this technology is only 4 years old, but in reality, it's 10 plus years old. And prior to that, as you said, you were in the industry printing with metal and everything in the aerospace industry. So the technology's been around for a long time. It's just really the adaptation and the adoption in this particular space. But in just those short 5 years since 2021, how far have you rolled this out globally? Because I know Australia is not taking it up at the same rate as anyone else. But if we just talk about global, and I want to be really clear, folks, Ahmed's based in Melbourne. Luyten head office is based in Melbourne. We are the center of the universe, and as he said, the leading technology company globally. But the adoption is taken up everywhere else. So how far is this taken up everywhere else, mate?
Well, it comes down to the market dynamics. And I will talk here, I'll bring another example, a great Aussie company that was established before us, and they were an inspiration to me personally. It's called FBR, out of Western Australia, Perth. They have a big robot that lays bricks.
They've been around for a very long period of time.
And their first projects were in the United States. With Luyten, because we were more dynamic in our offering, so we have printers that starts from 1 meter by 1 meter, and we targeted universities and people who do outdoors furniture and landscaping, pot planters. That helped us to get the numerics of how many printers out there quickly, and to help us also get feedback. Like we de-risked it for this, for these, if you will, build. Yeah, they're part of construction life cycle or ecosystem, if you will, and that helped us a lot. We have some of the best universities. We spent, as a country, a lot on this technology, and yet we realized that there's a company in Denmark where our country's R&D budget on this in universities, just to universities to give folks these PhD scholarships and all that, and then they go back to their home countries or go somewhere else. Compared to Denmark, it's a fraction of what Denmark had to spend, and they just rolled out the technology and learned into the market. And America was adopting this very strongly for a couple of reasons, which I understand. Americans were sick, especially if you talk places like Kentucky and the moving to the Midwest a little bit. There are hurricanes sometimes, all the way down to Florida. So they want houses that can be hurricane proof. For us, we've succeeded in that market because we've already worked on something that is cyclone proof, which is very close. We call it the ASNZ 1170. It's the code that deals with that kind of building requirements. In California, they had a huge disaster of 14,000 houses that were burnt, Altadena, Palisades, and they wanted fire-resistant houses. As we all know, what causes the fire normally to spread wide. Like you'd find the trees fine, but all the houses are burnt. It's the embers and the wind. So when we build with concrete, it's the most resilient material out there. You give people a better chance to resist those fires.
So the take over there has been much bigger. So
yeah,
just give us some numbers. In the interest of time, just kind of give us some numbers. How many, I guess, kind of units have been rolled out over there, and how many, I guess, how many houses approximately?
From our company, from our clients who bought printers from us, we're talking in the lower tens, because we're still scaling up our operation. So if Rob wants a printer right now, because you're in Australia, I probably can get it to you in 3 to 4 months maximum. But the orders you get from the US are a bit more significant. So people ask for 5 or 3, and we cannot do that yet. For good reasons. Is each of our products were, you want to see how much the product is needed. You need market pull, rather than market push. In our case, because it's a new thing. And once we felt that, okay, then we scaled to the number of units that we can sell right now. But in America, there are other players who are doing this, and there is no competition really. There is a shortage of 3D printers. Let's put it that way.
But you guys are in the US market, the Middle East market, in Asia, and also here in Australia as well.
And the UK. Yeah, so the first 3D printers in the UK was in Northumbria, upon Tyne, up there. So,
but it would be fair to say that those markets over there are doing much better than the Australian market at the moment. So we're here to try and go, how do we get this message out to the Australian community a little bit more? And people want to know the kinds of questions. How many of these have rolled out in Australia? And I know that the numbers are low, but they are still significant, folks. I want people to actually, whilst the number might appear like a low number, they're actually real. They're actually on the ground. They're live. There's people living in them now. Give us just a little bit of a state by state. How many houses are you aware of that have been completed?
So I'd say in Western Australia, probably 3 or 2, up to 5, if I'm not mistaken, or 9. There is another company that's making claims. I cannot verify those. In Melbourne, also in the 10s, 10 to 11. In New South Wales, it's a bit more happening. We're working now. We're talking about bus stops, dunnies, and in certain areas, duplexes, indigenous housing. So I'll say about the number of 20 in New South Wales. Queensland, most of our clients, every university in Queensland have got a printer from us. Some of the best researchers in Southern Queensland University, in QUT, in Griffith, they're like some of the top people. I know this Korean professor in Griffith who's have proved his materials and all that. But in terms of houses per se, we're not. I'm not aware. I know some of our clients have started building sheds that could be hay sheds that can resist fire. But per residential dwelling, I'm not necessarily aware of any. So yeah, that's the outlook. Tasmania, 0. We haven't done anything there, and
It's
but
predominantly those 3 states at the moment. So, yeah.
and the Northern Territory, of course, with Indigenous folks, we are doing these kind of like villa units. We worked with the Oronto people of Alice Springs, and it's a very exciting project. But also the rollout again is you're talking 5 houses, small numerics. Yeah.
So slow adoption at the moment, and hopefully with our message getting out there today, that people can actually start to see, look, the technology is real. It's being adopted globally. It meets all the standards. It's really just now, how do we start to think about doing the rollout? And then there's a whole bunch of factors that are going to go into that, including consideration of the design and also the process that you actually build a house, because it changes when you're using traditional building methods. The process changes to how you're doing anything with a modern method of construction, whether it be 3D printing, whether it be volumetric, whether it be kitted panels. You have to think differently, and it's all about front loading the design. So what they call design for manufactured assembly, DFMA, you have to think about that up front and go, well, if I'm going to be rolling out any of these new modern methods of construction, how do I plan end to end? Because these things are going to be precision machines that need things done down to, I guess, I'm not quite sure that the accuracy, but microns, kind of very, very accurate type things. But if you don't think about that accuracy up front, then you don't have time to be playing with it in the field while it's out there actually printing. Would that be a fair assessment?
Yeah, I would say so. Like the whole thing is, as a technology, at least ours, 3D construction printing, it addresses also the workflow. Our company specifically, we have our own software as well that has an AI agent where you can talk to it, say, okay, I want to my house to look like Rob's house, but looks better, and a little bit of parts that will look like Buckingham Palace. Then it will give you the whole working drawings, okay, all the way to the okay. So yes, we've run experiments where the printer will deal with the final working drawings, where the conduits will be, where the plumbings are going to be, and then the job for the plumber or the sparky. The sparkies also had to be a bit progressive. They have that drill thing. They send it through. It goes through the thing, and the time it took them to do these works was significantly shorter, and also precise. It didn't. They didn't have to come and complain about. And this is like a real survey we've conducted through our Office of Science and Research, along with the collaboration with the University of New South Wales. is that each of these tradesmen were asked, quotations were taken, uh, what are the common issues you get? Normally, the other tradesmen haven't done their job correct. So I had to do this, and haven't factored for that. And guess the cost from there on goes on and on. But in our case, it's 100 micron accurate, better than a heart surgeon.
Wow.
For the lack of better terms, there is no room to mess around. It's there. It shows here on the plan, and this is it. And
So,
that's
so your
fundamental.
your windows, your doorways, where your power points are going, it knows all of it right up front. It's not one of those things where afterwards you're trying to do a rough in and that sort of thing. It's going to print the hole for you. It knows exactly where to put it.
Exactly. And with that, basically, the whole idea for us is to get about 80 to 90% of the house to be 3D printed, other than the roof, other than the doors and windows, everything, kitchen table, built-in wardrobes, you name it, it's all 3D printed. So that's the kitchen
That's
island.
that's the ultimate goal.
And and we've experimented with that. And yes, there is savings. There is, especially in time, especially in terms of time, and the other services integration. Like you can have a functional house in such a short amount of time, talking weeks. Now, the other thing is yeah, you're right. You can define your walls to be even functionally superior, which gives us an edge over other methods, if you will, where we can make the walls to be soundproof or use certain principles that are out there. So it becomes a matter of your creativity, your architect's creativity, and I think that is very special. Everyone would like their house to be special, have a unique thing, which frankly would not afforded right now or offered that with the cookie-cutter systems out there, or the traditional way of design, which is averse. To give you an example, direct example, traditional way of design, architects are taught not to have any curves. In our case, because it will cost more to be able to achieve that. In our case, curves are encouraged. Sometimes we add curves just because it looks more organic. And I think we're tapping into something here. There is a reason people, I've never seen this before. People come and hug a wall. That's bizarre, for me. But I was like, okay, yeah, it looks more organic. It looks more closer to our nature. Maybe that's leading us to be more efficient. Yeah.
Yeah. So in thinking about designing up front, we've got a plan. And as we said, there's a whole bunch of things that we need to think about. In the early design stages, there's instead of getting the trades involved after when the construction is actually happening, we want to bring them into the design phase itself. What trades should we be bringing into that design phase? So there's a couple that are obvious to me, but might not be so obvious to others.
That is very good, actually. Yes. Not thinking or improvising on site. That's very important. It drives efficiency high, and everything is figured out before. Now, that doesn't mean that there will be room for folks to change their mind later, as long as it's not a structural beam or structural column. There is a workaround normally, but yeah, that's why all this technology is here to help us streamline the workflow, and that each of the trades comes and do his job. We're increasing the safeguards that you have right now, whether it's a powder soup or Coke cans or Tim Tams. You're always almost guaranteed within a very acceptable margin of tolerance that you'll get the same product.
Yeah, no, I understand. I guess my question was more, what specific trades, when we're doing the design of the house,
Yeah.
what specific trades do you want as part of that design process to make sure that you're going to get things?
So normally your energy consultant, your Sparky, your plumber, and of course for the windows and all that, so it's all the trades. In hindsight, now that I talk, yeah, all the trades, it would be better to have them at the room early on, have a plan. After phase one, phase two comes in, phase three comes in, and then it goes very smooth.
Yeah. So I guess to try and help people out here, you get your electrician involved because you want to know exactly where your points are actually going to be so they can bring those holes in. You want your plumber to go in because you want to know exactly where all the plumbing pipeline is going to go and that sort of thing. You might get your roofer in there because you want to know exactly where the roof trusses are going to attach and the like, so that the 3D printer can actually make those provisions as part of the design all up front. But it's really thinking ahead of that and not kind of at the end having to have what is called a rough in. Why break a hole into something? Why not just make the hole, right? So it's thinking those things ahead, and then when the Sparky turns up, he's just got somewhere where his conduit can go.
Yeah.
So it's those little elements, folks, and getting that what you said, 100 micron accuracy precision. So if we think about it clearly, we can get that design very nicely. So look,
there is no roughing here in our case. That's one thing, because the holes, normally there is a styrofoam circle or rectangle that people just take and squeeze things.
Yeah, very good. Okay, so from an actual timeline perspective, a lot of people I get to care about how long does it actually take to print a house? Because when we watch the videos, it's almost hypnotic watching the machine kind of print these things out layer by layer. But if I'm doing a typical 2-story house or 2-story townhouse, how long would it take me to kind of print that out? Understanding we'd need to put a slab in, and we may need to have, I guess, a slab for the second floor, or maybe we're going to put roof cassettes in. But just the printing part of that, what would that take?
Printing part, like for the multi-story house, I think we've publicized in the media about a year ago. 3D printing part took literally 3 weeks.
Yeah.
And that's because of one reason. The plan was that we will be able to finish it in 6 days. But here's what happened. We had a neighbor next door who complained that we cannot work after hours, although the printer was not making any noises. But there is a vibrator normally in the silo that have the thing, and they complained about that, and the generator, which was also. But anyway, and so with the normal day shifts, it took us, and weekends, obviously you cannot work weekends when you have a neighbor like that, who left when we finished the project, which was funny enough. Yeah. So yeah, it took about 3 weeks, about 4. About.
Okay. What we're saying is the technology is not limited. We're saying the local legislation with regards to noise and the like is the thing that actually slows things down.
In all honesty, we did this in a council called Wyndham City in western Melbourne. The council was very progressive, and they kept bringing the complaints and say, "Hey guys, this is great. You're doing something special here." All that. The local member, I think he used to be a school teacher. He came there enthusiastically as well. So it's overall, I'll say, councils, and there are councils that are chasing after press releases sometimes, but also do the wrong thing and go get any ad hoc product, if you will, and so. There is it's varying, but legislation and I think, in my opinion, certifiers in Victoria are out of control, and frankly, sometimes almost thuggish, and someone needs to look into that. Yeah.
Well, we won't go into the politics of the actual approval process. That's probably for an offline conversation.
Yeah.
But I guess people are like, we've not really talked about how the technology actually works. So we know that it's going to 3D print, and we know that it's those robotics. But let's just put together the elements, because you've touched on some of them. So we've got a silo that's going to, I guess, take all the concrete in the first place.
The raw materials, yeah.
The raw materials. And then you said that you've got a vibrator that's going to kind of get all the air out of all of that. So that's, I'm assuming, so it can, when it gets into the pipe, that I guess there's no gas.
air entrapment. Yeah.
So, air entrapment.
So the technology is okay. I can go at this briefly. So concrete is the science of making an artificial rock using chemistry. The chemical process here is called hydration, where cement is a binder that binds aggregates and sand together and make this artificial rock. For the longest time, we've been using formworks to make it look the way we know it, squares, rectangles, or some sort of molds that makes it look like Corinthian columns or Roman columns or Greek columns. 3D printing is free form. So if anyone here has done with a concreter, normally they have one test, which is the cone test. That is the most that can see the spread and temperature, a couple of parameters, and then you know this is a good concrete or not. In our case, it's more high tech. So there is a silo that sends materials in patches to a mixing unit. There is moisture sensors. That particular building we built in the city of Wyndham, we did it in the summer. At I think the hottest day was 42 to 43 degrees Celsius. No concreter normally would like to concrete in that atmosphere.
No.
For us, it was very easy. We were doing it with no, with no worry in the world because of the sensor, if you will, fusion technology that we had. And then it goes all through a piping system that goes through a robotic crane or a gantry or a robot, and then extrudes what we call the geometric code layer by layer, and give us that ability to do things in free form. So that's the technology in a nutshell, and it's concrete. Or some folks use structural mortar. We use both. Some has challenges more than others. Structural mortar normally have a little bit of cosmetics. Sometimes we call it shrinkage cracks, but that's a design problem. People who don't understand that you can't just put an expansion joint every 6 meters like you do with the brick and mortar. This is more specialized. So that's where some of the challenges. Yeah.
Yeah. So, and for you guys, you've also got a proprietary binding agent that brings all of that material together so that it has a certain viscosity, so it pours out of the nozzle nicely, and so I guess dries in appropriate timelines to be structurally hardened appropriately by the time you put the next layer on and that sort of thing. So it allows, yeah. So that's your proprietary secret sauce, for want of a better word. So
it's called Ultimate Creed.
Ultimate Creed.
Yeah, Ultimate Creed.
And so that's the secret sauce that you guys have got over and above anyone else's technology to make it kind of alleviate some of the challenges that you're talking about. Obviously, there's going to be expansion joint requirements as part of the design process and a couple other things like that. Yeah. They're not problems; they're just things to be thinking about in that design phase, folks. It's
to consider.
Considerations. That's right. Yeah.
I have to plug in my laptop. If you give me a second.
Okay. I'll keep talking while you do that.
Okay.
So the gist of this, folks, is there's a whole raft of things that you can actually do with this new technology that you can't easily do with normal physical construction because of the extra work and labor that's actually required. As Ahmed was talking about, previously you would design curves out of a building because they were going to be very expensive to do. Now you can actually design them in. So now you can actually be more creative in your designs. You can have things like overhangs on your designs where I guess the wall kind of has a lean to it, so to speak, but it's actually by design. So there's a whole bunch of elements that can actually go in from a design perspective. Oh, we've lost him altogether. His laptop's gone. So hopefully you can plug that in and get back in time. Otherwise, I might have to wrap this up. But here he is. He's back. Well done. We're worried about you, mate.
Oh, no, phone died. The computer died on me.
That's okay. We made it back. We're good.
Yeah.
I was just saying that I guess the variations in designs that can actually be done. Look, obviously you guys are the manufacturer of the robot that actually does this. This is something that from a developer's perspective, what we need to be doing is actually talking to our architects and saying, hey, architect, can you design for manufactured assembly and take into consideration technologies like 3D printing? That then gives the builder, I guess, the opportunity to then go, hey, I want to use these modern methods of construction, whether they be 3D printed, whether they be volumetric designs, whether they be, I guess, kit of parts. There's lots of different modern methods of construction, but you have to design for it up front, and that front loading of the design is super important in that. The challenge that we've got at the moment is builders can't build any of this stuff if we are not doing the designs appropriately in the first place. Okay, so if we keep giving them a traditional build, that's what they're going to keep traditionally building. And so whilst the builder is going to be the guy that buys the machine off Ahmed, we need to be the one that's actually giving the job to the builder to actually make him want to buy off Ahmed, right? And I guess the speed of doing this, the efficiency of doing this, they're all things to consider. Not necessarily a reduction in cost of construction. I want to be very, very clear. It's not necessarily about that. What it is about efficiency and effectiveness, the creativity, the opportunity to open up, I guess, more variety. But you can imagine once a machine is on site doing its thing, the amount of labor there is going to be much less. So that same builder can be rolling out multiple projects at the same time. They can be rolling from one project to the next. So the same builder can build many, many, many houses over time. And it's only through that efficiency of build that we're actually going to, over the longer run, bring the cost of everything down through volume, right? But while there's only a handful of things happening, the volume play isn't quite there yet. Anything you want to add to any of that, mate? That was me kind of prattling on a little bit.
No, that's about it, actually. Yeah, like it's a matter of awareness for builders to understand. And here is what I would tell builders, and especially ones who bought from us. You have invested in your freedom in a way that many would not necessarily understand on the onset. If you're a project manager, and imagine if you can reduce a number of trades and increase the efficiency and the quality, and rather than doing 5 houses a year, you can probably print about up to 50. Then you can, rather than undercoating, rather than keep complaining and being sad, you can actually keep more money on the table.
Absolutely.
And make your business more efficient and sustainable. We see that with metal works. Okay, many were allergic to laser cutting or water jet cutting. So it's fine to manufacture anything in Australia. It used to be very expensive. But once we saw the rollout of some of these machines, it became something that, sometimes metal works are cheaper. Sometimes the light gauge steel could be cheaper than the timber Just as an example, it depends on the jurisdiction and which company you're dealing with. So there are these things that obviously, along with time, scales, mathematics of scales will takes its effects. Having said that, remember the freedom part is more certainty with your projects. That means more time thinking about next steps, about expansion, rather than being I realize many builders are still in, if I am not there, nothing operates well.
Yeah.
Here we're talking about a different system where, you don't have to be there, mate. You can watch the printer from the comfort of your home while you're planning the other project or other meeting. And you can see what is happening, what is not happening, and real time data doesn't lie, doesn't tell you, we're almost there, boss, and it was a smoke break all morning. So that's that's the real thing that I'll advise builders to think about, and being part of the change. If there is change and you decide to lead, you'll be one of the biggest winners.
And I think that's a really important note to end on, Ahmed, is that being part of the change, the Australian construction industry has been stagnant for quite a long time with regards to the technologies in use. But you, as the small scale developer, have the power to actually change that, to impact the industry in a very, very positive way. A whole range of modern methods of construction, including the 3D printing side of things, design for it up front, design for manufactured assembly, think about thinking differently. That will allow the builders opportunities to do things differently, faster, more efficiently. The builder's going to be more productive. They're going to be more effective. The likelihood of them falling over, which is one of the biggest risks in the industry, is so much less because the house gets done in a much shorter period of time, more precise. The quality of the build goes up, and a whole range of factors that all come into play. But it all starts with you guys out there going, hey, wouldn't it be great if I had one of these houses on my block?
Can I add one?
Absolutely, mate.
You'll have even better employees, happier employees, folks who understand precision, folks who understand efficiency. And it's highly unlikely that you find an 18 years old who wants to be a brickie for the next 40 years. I think it's also very important to understand that as we're going forward, we're dealing with Gen Z. It's the most impatient generation.
Yeah.
And it will be very, very appealing for a lot of those, because I can tell you right now, no one coming from overseas will try to be a bricklayer. Those days are long gone, and it's counterproductive. It doesn't benefit this country.
Yeah.
Smarter people coming, and we need our folks here to be smarter and to do things that that is more comfortable for them, where they can flourish better, to give them a fair go. Yeah.
Okay, well, on that note, mate, we will wrap it up. For those of you who are new to our channel, just to give you some heads up that we run physical events all the way around the country. Not only do we run these YouTube channels, but we have industry experts, real deal presenters, masterminding and networking in 4 states, Brisbane, Sydney, Melbourne, and Adelaide, and Perth, where I'm currently located today. We are just about to launch in the Perth community any second now. So we have already published some pre-launch activities where we want you guys to get really involved. We've already set dates. We've got venues, the whole lot. Folks, we are coming to town, so looking forward to that. And the other big news happening around our community is our upcoming 2-day event called Developer Launchpad on the 28th of February and the 1st of March. That is all about how you can actually learn how to take advantage of a whole bunch of legislative changes that have been happening in the last little while to give you faster delivery timelines and more density in areas that you probably didn't even know existed. So all of that said, mate, Thank you very much for your time today, Ahmed. We are going to be visiting Ahmed's factory in the next couple of days, and we're going to take quite a few videos and do a little bit of a recording of kind of inside, behind the scenes, folks. So watch out for that one. Looking forward to meeting you in the flesh, mate. So I'm going to say till then, bye for now.
My pleasure. Thank you, Rob. Thank you.
See ya.
Have a good one.